All right, welcome to The Explainer. Today, we're going to be cosmic detectives. Our crime scene? The solar system itself. We're on the hunt for clues, trying to figure out the grand design that holds this whole thing together.
So, let's just jump right in. Have you ever really thought about it? Why our solar system isn't just a total mess? A chaotic jumble of rocks and gas all over the place. A cosmic free-for-all. But it's not. It actually follows a set of really clear patterns.
And you know what? Understanding those patterns, well, that's the key to the whole mystery. So we're going to tackle this just like a detective story. And we'll start with our main suspects, the planets.
Okay, first big piece of evidence. The planets, they are not all the same, not even close. In fact, they're split into two totally different families, living in two completely separate neighborhoods.
And this right here lays out that fundamental divide perfectly. See, on one side, you've got the terrestrial worlds. They're small, dense, rocky, and they're all huddled up close to the sun. But on the other side, you've got the Jovian worlds. These guys are enormous, gassy, and not very dense at all, and they're just roaming the huge outer regions. This split, this is our first major clue.
So, to really get a handle on these two families, we gotta do some more digging. Let's go check out some of the most extreme members of each group and see what kind of secrets they're hiding. Okay, so you'd think the answer is Mercury, right? I mean, it's the closest planet to the sun, our system's giant furnace. But, in any good mystery, the obvious answer is almost never the right one. So here is the million-dollar question. Why is the second planet from the sun hotter than the first one? The answer to that is a massive clue about what makes these inner, terrestrial planets tick.
Get this. The surface of Venus is a staggering 470 degrees Celsius, day and night. That's hot enough to melt lead. And the atmospheric pressure is 90 times what we feel here on Earth. It's like being a kilometer deep in the ocean. Just incredible.
And that right there points to a key piece of evidence about these terrestrial planets. It's their atmospheres that define their worlds. Mercury has basically no atmosphere, so it has these wild temperature swings. But Venus, its super thick CO2-rich atmosphere creates this runaway greenhouse effect. It just traps all that heat, making it the hottest planet around. See? It's all about the atmosphere.
Okay, so now let's head way out to the outer solar system to check in on that other family, the Jovians. And we'll start with the king, Jupiter. It fits the family profile perfectly. It's not made of rock or metal. Nope. It's made almost entirely of hydrogen and helium, literally the same stuff our sun is made of.
And then there's its spectacular neighbor, Saturn. It shows off another signature feature of these gas giants, those incredible ring systems. Now, they might look solid from a distance, but they're not. They're these huge, sprawling fields of countless little chunks of water ice. And each one is orbiting like its own tiny moon. And get this for perspective, they're so incredibly thin that if you could shrink them down to the size of a football field, the rings would be thinner than a single sheet of paper. Just wow.
But wait, the evidence doesn't just stop with our 8 main suspects. The smaller stuff, all the objects scattered throughout the system, they hold just as many clues about what really went down here.
So you go out between Mars and Jupiter, and what do you find? The asteroid belt. And what's it made of? You probably guessed it. Rock and metal. See? It fits our pattern perfectly. The rocky stuff, it stays close to the sun.
And then, as we keep going way out past Neptune, the material changes. Suddenly, we're in the Kuiper Belt. It's this huge region of icy objects. And this, of course, brings us to the famous, let's call it a cold case, of a demoted planet, Pluto. So, why isn't Pluto a planet anymore? Well, it's because it hasn't cleared its neighborhood. Think about it like this. A real planet is the undisputed gravitational boss of its orbit. It's either sucked up or kicked out anything else big that gets in its way. But Pluto lives in a crowded cosmic block party with tons of other big icy neighbors. And if we go even further out, to the absolute edge of our solar system, we hit the Oort cloud. And what's out there? You guessed it, more ice. Trillions of comets. The evidence is just overwhelming at this point. Our solar system is sorted. It's rocky on the inside, and it's icy on the outside. Okay, we've gathered all the clues. We've got two totally different families of planets, one rocky, one gassy. We have a crystal clear pattern of what they're made of, rocky stuff inside, icy stuff outside. I think we're ready to solve this thing.
The solution to this mystery isn't about what the solar system is like today. It's about how it was born, something like 4.6 billion years ago. The key is in the origin story.
And the answer is what's called the solar nebula theory. It all started with this giant spinning cloud of gas and dust. Gravity started pulling it all inward, causing it to collapse and flatten out into this big spinning disk. The center got super dense, super hot, and boom, it ignited to become our sun. And this whole process, it naturally sorted all the materials. In the hot inner part of the disk, only things like rock and metal could solidify into little planets. But way out in the cold outer disk, ices could form too, and that's what built the huge cores of the gas and ice giants.
And you can't forget the star of the show, literally, the sun. It's the real heavyweight here. We're talking about 1,000 times more massive than everything else, all the planets, moons, asteroids, and comets put together. Its massive gravity was the conductor for this whole cosmic orchestra.
So you see, this beautiful, elegant order we see today, it's not an accident. It's a fossil record. The whole layout of our solar system is a direct leftover of its birth, from that spinning, sorting disk billions of years ago. Case closed.
But that leaves us with one last really fascinating question, doesn't it? The same laws of physics that built our solar system are at work everywhere in the universe. So as we look out into the galaxy, how many other cosmic neighborhoods are out there, built from the very same blueprint, just waiting for us to find them?